Hello. In this video, I'm going to share with you a video demonstration of my web API health tracker, which is a RESTful API health tracker with a web front end while utilizing Agile tooling and techniques. So I'm going to share with you the front end, and then we'll jump straight to the code to show how the front end and the back end are hooked together. So first things first, this is the visual representation. And as you can see that we're using the route from OpenShift. And as you can see, also the builds of the actual application are all run successfully. And I was just sharing with you the actual route. And for the backend, we're using PostgreSQL. And I'll share with you the database in just a moment. But yeah, first things first, as you can see, these are all of our users. And I'm just going to demonstrate deleting a user, right? And then I'm also going to share with you how that is reflected in the database. So I'm going to quickly log into the database and I'm going to select all of my users. So you can see these are all of my users. And yeah, similarly here. Now let's say I delete a user. Let's say Tom Folden is being removed. And as you can see, Tom Folden was there, number with an ID of 6 in the database. Now if I refresh the database, as you can see, number 6 is no longer there. ID has been removed. And so the database is being reflected in real time. And so now we can delete the user and we can also edit a user. For example, let's say Claire Smart. Claire Smart though. Similarly, it will be reflected. So Claire Smart, it will be reflected Claire Smart though. Okay. Now let's test adding a new user and activity. I'm going to call this user Mary Doe and at gmail.com. So user has been created successfully. I'm going to create a new activity for this user. Let's say a walk for 30 minutes. I'm going to create the activity for the user. And we can view the activity in a map. As you can see, there's no distance yet, duration and average speed are also visible. There's also no route characteristics yet. And let's say Mary Doe is going to walk along the key. So they can plan their walk by entering the actual route, okay, by adding the points on the map as such, right? Okay, and then they can click the last point or they can press finish route and then they can save the route. So the route has been saved and it's going to display as such. And if I click out and see, as you can see, the data has been saved and total distance and the average speed and the number of points they have entered. And we've also got some angles on the route efficiency, either how many turns or is it straight? How is it efficient? And similarly, I can create multiple activities as you can imagine. And now this was an inspiration clone of the GPX Studio, where users typically, map out their routes and that they have walked, and they may not have, some sort of track on them, so they're able to input this on the map, and they can export it as a GPX. So that was the main inspiration, and we can do that too, right? So as a user, I have entered my route, right, or multiple activities. I can export this as a GPX. Right, and I can call this, say, my activity walk. Okay, so it's saved, and if I navigate to Strava, and so you can see it expects the GPX, so I can find my activity walk. Okay, and that's it. So the title of the walk, and etc. And I can hit save this activity, and it's displayed just as expected. Right. As expected, I can also edit the points. Let's say I want to change my specific route. So we have quite applications for editing specific points. So I can click on the point, I can delete the point, or click on another point, delete it, and delete the first point. I can also, let's say, delete this point, delete that point, and I can extend points. Right. It is responsive. So if I navigate to a smaller screen, I can scroll down, I can edit the activity, I can navigate the specific activity. I can go back, I can also scroll to a different user, right? Navigate the activity, see their routes. Also, I can export. Spend too much time here. But as you can see, we have tests that are where we've developed this further to have tests for CI when PRs are open and TR and validating the status of tests to ensure that they're constantly running and passing. And we have labels to confirm this. And we use a code call for our code coverage. So for the actual test, as you can see, for one of our CI tests when we deployed OpenShift, we are, creating the artifacts that are produced during runtime, such as the KDoc and also the target artifact repo. The KDoc documentation site includes all of the comments of our code, right? And which is one of the artifacts that is created. And for the code coverage, as you can see, most of our coverage is 100%. And yeah, if we jump straight to the code, and yeah, so this is a Maven project. So we have our POM file with all of our POM.xml file, all of our properties and dependencies and relevant profiles and build plugins. So, and if we quickly view as you can see from the test, all of our tests are passing, and our code coverage is more accurate than code conf, even though code conf says above 91%. Here we have a more direct reflection, which is 100%, 99 plus code coverage. Okay, and yeah. So first things first to note is the test folder. So it's all our test folder where we test everything. From our database utilities, our GPS services, our helpers, right? And also our data access objects as expected. Obviously our controller to ensure functionality is represents the relevant context. And the main application start is this main method, which starts the database configuration and registers all of the configured routes. So the database connection it utilizes this method, this class in the configuration folder. What it does is essentially registers gets the database connection of either localhost or or based on the environment that we're currently running on, either localhost or on OpenShift using PostgreSQL database that we've seen earlier. And if it's localhost, then it provides the relevant schema. Right? We actually have test data to ensure that the application has been injected with correct data and is reflected correctly. And else we register the database that our environment is currently running on, in this case OpenShift PostgreSQL database. And so we're connected to our database, and so when the application starts, it registers the specific routes. In this case, we are registering routes, remember, using CRUD operations, get, post, delete, patch, etc. And for each specific route, we register view components, for example, home page or overview. And when we register these view components, we effectively use the retrieved data from these routes and inject them into these components. And we know this because the HealthTracker controller provides the relevant context and returns the actual JSON data, right? Utilizing its methods, right? After it has been provided with that context as an argument. Okay. And if we take a look at the HealthTracker controller, the HealthTracker controller, as you can see, it gets that context, and based on a specific ID, it returns that JSON object for either deleting activity points or deleting activity points metadata, right? And it knows the relevant structure of the actual object that it's to use, right? And because we utilize the actual objects from, we almost like instantiate the objects from the data class of the specific user, or that specific user in question, right? Also the data points. And the actual user. So what's important to note is that we have we have users. Users are tied to a specific activity, and activities are tied to a specific activity point, and that's really the core structure of the web application. So what's important to note is that we have Kotlin for our backend and resources for our front end. So for the front end, if you can recall that we have the specific routes for the view components, right, which renders the view components, well, HTML with view components, and and within that specific routes uses the data that we have retrieved from the health tracker controller, for example, and that returns the JSON data. So the actual view resources is what's rendered, and these are the components that are rendered. And for example, first things first, for view, we have the actual page, the HTML page, which is where we utilize Font Awesome, CSS, and all of our relevant scripts that our front end will use, and all of our components. And for the actual views on the page, we have homepage, because it has the ID here, which is what's actually used which is the ID used within the actual Javelin configuration. It's just basic HTML, but on specific UI sections, we show the user in question using dot notation, and that's it. Right at the bottom of the file, as you can see that when we're registering the specific component, we show all of the users, ensure that we show the correct user's data, right, and register the correct data for that specific user on that specific route, right? And similarly for all of their activities. And that's it. Thank you.